Welcome back. We're just going to continue along with a few more examples. In this one, we have a couple of things that are happening. We have addition and we also have multiplication. So if we remember our order of operations, multiplication comes first before we do addition or subtraction. So that means I'm going to deal with the multiplication part of this problem first, then I'll deal with this x over x minus 3 afterwards. So I know, of course, for multiplication, I don't need to make common denominators. So I'm going to start off by factoring. And once I've done my factoring, I won't make common denominators. I'll just do my multiplication first. Then I'll think about making common denominators afterwards. So the only thing that needed to be factored was really that x squared plus 6x plus 9. And multiplying to 9 and adding to 6, that's 3 and 3. And I can see for my two rational expressions that are being multiplied that they both have an x plus 3 as a factor. So that means I'm able to cancel out those x plus 3's. So for the second term now, what I should have should be just an x minus 1 in the numerator and an x plus 3, x minus 3 in the denominator. So I've taken care of my multiplication, and now the only thing left for me to do is the addition. And of course, if I'm doing addition, I guess I need to make a common denominator. And I've already factored things as much as they can be factored. So I guess what I need to do now is notice that both of my rational expressions already have x minus 3's. The second one has an x plus 3, and the first one doesn't. So I'll multiply the first one top and bottom by x plus 3. And now I'm ready to go. They both have the same denominator, so I can combine them together and say that we've got one big fraction all over x minus 3x plus 3. And so what will I have for my numerator? I'll have the first numerator plus the second one. For the first numerator, x times x plus 3, or if I were expanding that out, x squared plus 3x. And then for my second numerator, I have x minus 1. And so this adds to give me x squared plus 4x minus 1 for my numerator. So if we're looking at that, of course, we should hopefully try to factor it first and then see if anything cancels. So if we're looking at this numerator, x squared plus 4x minus 1, there are no common factors. It's not something where you can do a factoring by grouping. It only has 3 terms. If we try to factor it by finding two numbers, we'd be looking for two numbers that multiply to -1 and add up to 4, and there are no numbers that do that. So it looks like that numerator doesn't factor any further, which means we are finished. That's the end of our problem. All right. Oh, one more. Division. So, of course, if we're looking at a division problem, division is the same thing as multiplication or can be turned into multiplication. Remember that when you're taking one fraction and dividing by a second one, you can rewrite that as a multiplication problem by taking that second fraction and flipping it first. So instead of dividing by x plus 1 over x minus 2, we'll multiply by x minus 2 over x plus 1. And then now that we've got it as a multiplication problem, it's relatively straightforward. All we need to do is factor our numerator and denominator for that first rational expression. So we've got a difference of squares. We have x minus 2, x minus 3. And then I notice I can do a little bit of canceling. I have x minus 2 as a factor of the numerator and the denominator. I've got x plus 1 as a factor of the numerator and the denominator. And so the only things left over now are just x minus 1 for the numerator and x minus 3 for the denominator. And that's kind of a nice little lead-in to the last little topic to mention here in 1.6, which is complex fractions. What if we have fractions inside of fractions? So something like this expression here at the bottom, this would be an example of a complex fraction or a compound fraction, where it's a fraction and inside of the fraction, in the numerator, there's fractions, and in the denominator, there's fractions. There's a couple of approaches that we have to help us simplify complex fractions. One of them, which is the one that I don't like as much, is to make common denominators on the top, combine them together, make common denominators on the bottom, combine them together, so that you now have just one single fraction on the top and one single fraction on the bottom. So in other words, do a bunch of algebra till you get it to start to look like the beginning of the problem that we just did, one fraction on top of another. And then you can do what we did in part D and just flip and multiply, and then you're pretty much finished. We do have to be careful here that the flipping and multiplying, that only really works when we're dividing by one single fraction. That's why this is sort of a more labor-intensive way of doing things, as we're going to see. So if you just had one fraction on top of another, like the 2 over x divided by 3 over y, and you wanted to flip and multiply, yes, you'd be totally right. That would be correct. But if you had two things in the denominator, it's not enough to flip and multiply them individually. Unfortunately, that is not correct. So if you decided you wanted to go down the flip and multiply route, before you could do that, you would have to combine these two fractions together to make one single fraction. And to do that, you'd need to make common denominators and do a bunch of extra work. And then eventually you'd be able to flip and multiply. So we're going to see an example, and I'm going to tackle it that way first, and then I'm going to show you a second way, which I think is a little bit faster and a little bit nicer. So with this one, if we're looking to simplify it, there's only one little bit of factoring that needs to happen here, and that's, I notice that x squared minus 4 factors as x minus 2x plus 2. And so if I decided I wanted to do what I was talking about previously, making it one fraction over one fraction, then on the top, I notice I've got 5, which is the same thing as 5 over 1, and I've got 1 over x minus 2. So if I wanted to make a common denominator, then for the 5, I would need to multiply top and bottom by x minus 2. For the denominator, if I wanted to combine these two fractions, they both already have x minus 2's. The second one needs an x plus 2, so I'll multiply the second one, top and bottom, by x plus 2. So what does this give us now? So in our numerator, we have one fraction over x minus 2. And what do we have? Well, we have 5 times x minus 2, or in other words, we've got 5x minus 10, and then plus the 1. In our denominator, we have two fractions that are both with x minus 2x plus 2 for the denominators of them. And so what are we going to have in the numerator? Well, we'll have 3 from that first fraction, and then we'll have 2 times x plus 2. We'll have 2x plus 4 from the second fraction. So I've started off with the numerator. I made common denominators and combined them together. For the denominator, I took those two fractions, made common denominators, and combined them together. I still need to do a little bit of simplifying. So on the top, 5x minus 10 plus 1 is really 5x minus 9. And 3 plus 2x plus 4 is the same thing as 2x plus 7. So now we've got it in the same form that we had as question D from a couple of slides ago. One fraction divided by one fraction. Now we can turn that into multiplication. I can say, well, that is the numerator multiplied by the reciprocal of the denominator. And if I'm looking at cleaning things up, I notice that I've got x minus 2 as a factor for both the top and the bottom. So I can cancel out the x minus 2. And what does it look like this leaves me with? Well, in the numerator, I have a 5x minus 9 and an x plus 2 being multiplied together. And in the denominator, it looks like I just have 2x plus 7. So just sort of circling back, what did we do? We started off with making a bunch of common denominators, combining things together to make single fractions. Then we were able to do flipping and multiplying and a little bit of canceling to get to our final result. I mean, that certainly will work, and that's always an option that's available to you. But I'm going to suggest you try at least a few times this other approach, which it's going to start off the same way. We're going to begin by factoring both the top and the bottom, making sure everybody's as factored as they can be. So I've already done the factoring once before, so I'll just sort of copy it down here. So x minus 2x plus 2. And now here's where we do something slightly different. What we're going to do now is look at all of the fractions that we have in the top and in the bottom and ask ourselves what would be the common denominator. So if we look at the three fractions that we currently have, and if we were to say what's the common denominator for those three fractions, the answer would be x minus 2, x plus 2. So what we're going to do now is not make common denominators, but instead what we're going to do is for everybody on the top and everybody on the bottom, we're going to multiply them by x minus 2, x plus 2. This is not the same thing as making a common denominator, so I just want to be clear on that before I go further. I'm not going to take this fraction and multiply top and bottom by x minus 2, x plus 2. Instead, what I'm going to do is take this single fraction and just multiply it by x minus 2, x plus 2. So what's going to happen for us? Well, let's see. The first one is probably nothing very shocking. If we were to take 5 and multiply it by x minus 2x plus 2, you'd get 5 times x minus 2x plus 2. Probably nothing really surprising there. For the second term, if we were to take this fraction and multiply it by x minus 2x plus 2, the x minus 2's would cancel, leaving just the x plus 2 left behind. So that means in our numerator now, we no longer have any fractions. And we'll have the same thing happen when we multiply our denominator by x minus 2x plus 2. When we take that first fraction and multiply it by x minus 2x plus 2, the x minus 2's and the x plus 2's all cancel, leaving just the 3. When we multiply the last fraction by x minus 2x plus 2, the x minus 2's cancel out, leaving just 2 times x plus 2. So now we've got a much simpler thing to deal with. We don't have to deal with fractions inside of fractions. There's no flipping and multiplying left to do. The only thing left to do is to just simplify the numerator and simplify the denominator. And in fact, we're almost finished. If we're looking at the numerator, you'll notice that we've got two big terms, both of them involving x plus 2's. So from both terms, I could factor out x plus 2, leaving 5 times x minus 2 from the first term and plus 1 from the last. For the denominator, I just need to do a little bit of expanding. And then now I'm pretty much finished. In the denominator, I would have 2x plus 3 plus 4, or in other words, 2x plus 7. And in the numerator, I'd have x plus 2 times that second bracket. And that second bracket, when I expand and simplify, I would have 5x minus 10 plus 1, or in other words, 5x minus 9. So I get exactly the same answer as before, but a little bit faster. Within one step, I no longer have any fractions inside of fractions to deal with, as opposed to the previous way where I stayed with fractions instead of fractions for several steps as I'm making common denominators and putting fractions together, and it's not until I flip and multiply that I'm no longer dealing with a compound fraction. This approach, my second one, I think it's a little bit faster and a little bit easier. But of course, either one of those two approaches will always work for you.